We're going to continue with overload devices. Thermal overload mounted on the compressor dome reacts to high heat by opening a circuit wired in series with the common wire. Internal overload factor installed in the dome open circuit on high heat. All compressors that I know of have one of these devices in the top of the compressor because that's where most of the heat goes. This device will fool a lot of new techs and some experienced techs. Pay close attention to this device. What happens is when the compressor overheats, it can happen when it's low on refrigerant, it can happen when it's high on refrigerant. It can happen under conditions where the air is blocked on the condensing unit. There's a lot of factors that will cause it to happen. The compressor could be old. There's many things that can cause the temperature in the compressor to get very hot. Well, what these items do is they keep the compressor from seizing up, from the parts all getting so hot that they expand a little bit and lock up. This device is built inside the system. You can't see it. But what happens is that little switch inside that little black box in that picture tube will open up and stop the current. One of the legs, which is in this case and in most cases I know of, is the common wire, which is one of the 120 or 115 volt wires going to that compressor, making up the 230 volt single phase power source. It will open up, and since one of them's open, nothing works. This item, if you think about it, have you ever seen a blinking light on a Christmas tree, light on a house Christmas lights? That blinking light has a very small switch just like this in it, much smaller, much less exact. But what happens is, as that bulb heats up, that switch opens. It knows it's too hot. Then it cools down and closes. That's what causes the blinking. That switch is opening and closing on that little light bulb base. Well, this does the same thing, except this is censored much more closely related to what would damage the compressor. So when it gets up to that temperature, whatever the manufacturer is, that switch opens, and until it cools down. Probably the number one reason this happens is the condenser fan motor on the top of the unit stops turning. So the compressor has no way to dissipate all that heat and causes it to switch off. The best way to get this system going without waiting an hour sometimes it takes a while depending on how hot it is outside and the sun, is to get a garden hose. Shut the disconnect off, even though you don't need to do that, but you don't want that fan coming on when you're spraying water on it, because then it'll spray right up at you. Turn the disconnect off or turn the thermostat off on the unit. Take a garden hose and just let it water pelt the top of this. It's safe. Remember, this is an outside unit, rain gets all over it, but just let the water run on the top of that compressor. It's still going to take 10 or 15 minutes. It's not going to be quick, but it's better than waiting an hour for the system to restart itself again. Crankcase pressure regulators. I've only seen these on some commercial systems, normally refrigeration systems. High crankcase, low pressure can draw high current. It trips the overcurrent device to stop it from damaging motor and windings. Discharge line safety device. Pressure switch shuts off compressor when head pressure gets too high. Thermostat shuts off compressor for high discharge line temperature. On high side, pressure and temperature rises and falls together. This item you'll see in the top description, the pressure switch for the discharge line, you'll see in the majority of the units you look at that do home residential air conditioning. And it looks just like this. It's soldered on to the discharge line inside the condensing unit. This item is there for when there is TXV has a blockage in or shut down, or the metering device is not put enough through. There's other reasons why it happened. It could have a dryer. The liquid line dryer can be plugged up, or there could be other reasons. It could have too much refrigerant in it. But what happens is when the pressure gets so high that the compressor is ready to just shut off because it's overheated, or it is ready to lock up, this switch shuts off, turns off the compressor, and that after the pressure releases a little bit, it will come back on. It resets itself. Sometimes you walk up to a unit and you'll see this compressor turn on, shut off, turn on, shut off, and it'll be constantly doing that. That's that switch. Sometimes it's not the system. Very important point. It's the switch that has gone bad. So it's not the compressor really bringing that much pressure up. It's the switch inside bad. Just a little pressure will set it off. So this is what you find a lot. The Heil units usually have one built into the system. There's a little orange switch, usually down by the refrigerant lines coming out of the unit, that you have to push to reset. They're not auto resetting, because they know if this goes off, there's a problem, and they want you to call a technician, at least the homeowner call a technician, and say, hey, I got a problem, my unit's not working. Well, he goes out, hits that switch, it starts up. That's not the time to leave, give him a bill and leave. It's the time to figure out what's causing that to happen. Now, the one thing they don't mention in this chapter, which is another surprising thing, like the thermostat, there's also low pressure switches that turn off the compressor. For example, if your compression is really low, if you're missing, half your refrigerant, or maybe even as little as a third, that switch will shut off, because again, that compressor uses the return refrigerant vapor from the evap coil to help cool that system. So if you don't have enough refrigeration in the system, you don't have enough oil, you don't have enough cooling, you can cause the compressor to fail. So most units will have two of these. They'll have one on the high pressure line, the liquid line, or the discharge line, and they'll have one on the suction line doing the same thing. Now, if they don't have one built into it and you're putting this unit in, and you're given any type of long-term guarantee on labor as well as equipment for 5 or 10 years, you can make these, you can get these and put these on yourself. And if you don't want to solder it in, they make an item that you put with a T on the outside by the service valves, and you can put one externally on this system for both these if they don't already have with them. Most manufacturers put the discharge line and the suction line low pressure switch in their systems. Accumulators. On residential air conditioning, you will not see these very often in straight air conditioning units. Usually they're in heat pump units, quite a few of them in heat pump units. I think, I don't know of one heat pump I've ever worked on where they weren't on there, but I'm sure there's some. This tank is on the suction line with an inlet and outlet at the top. It traps liquid refrigerant to prevent from entering the compressor. Remember, your compressor is a vapor pumping device, so you don't want liquid coming back from the evap coil and causing the compressor to fail. It does more than just is harder to pump. It also is caustic, and it will wash the oil off the inside of the cylinder. So you want to keep liquid from going back to the compressor. And you can see the diagram here. The liquid goes in on the top left-hand side. It fills the case, and liquid falls. Any vapor will move to the top and go into the tube and continue the suction cycle. There's also a little oil hole port at the bottom to get oil out of the system. This mentions some include a liquid line coil at the bottom. I've never seen that before. I'm sure it's out there, but it's not a common device, and this keeps the oil and the liquid refrigerant warm, because these are one of the first things that freeze up when you have a system low on refrigerant. You'll see this canister inside the condensing unit freeze up. Here's a caution: accumulators should be covered and insulated as well as the suction line. That's true. Almost all suction lines are covered. They should be, or they weep, which is not a horrible thing outside, but inside it would be. But you're trying to keep the temperature of the refrigerant from changing from the outside temperature. You only want it to absorb the temperature inside the home. The accumulator, I've never seen one insulated. This is another odd thing that the book covers. I've seen thousands of them, multiples of thousands of them, and never seen one insulated. But I see their point. It probably should be insulated, but it does hold a lot of vapor refrigerant or gas in it, so you don't want to change the temperature of it. Insulation prevents condensation from forming. These units, speaking of condensation and why they don't want this to happen, is because they'll rust out. These are not made out of nice copper. It would be too expensive. These are made out of just normal steel, and they're painted. So if you find a unit that's missing paint, they usually don't sit on the bottom. There's usually a little leg or a screw at the bottom to hold them off the bottom, because if they were to sit on the bottom of the unit, a lot of moisture in there from rain or whatever, this unit, once it gets the paint rubbed off, it's going to, even though it's full of oil inside, there's no oil on the outside, it's going to rust. Inspect regularly for rust. You can use a little paint if you find some and touch it up. I don't know if it would stop it. They're not very thick sided units or bottoms, so they do fail. Probably about 10% of the leaks you'll find out in the field will be from accumulator bottom. And it's easy to spray a little soap on it, you find it. A rusted accumulator should be replaced. Well, in that case, you'd be replacing them often, because most of the units that you see that are over 5 or 10 years old have a rusted accumulator on them. So it's one of those things that on an older system, I don't know if it's not leaking, it would be worth doing, but sometimes they need to be replaced.